In this tutorial, we will learn how to develop CFD domain in external geometry software. But before do that, let's learn how to save the project. So in ANSYS, you will save the project in workbench file here. So as you can see, our geometry is done. So there is a green sign for that. We have to do meshing and case setup, solution and result. This whole data set should be saved for future use. So to do that, go to file and save as. So if you go to save as, it's better to create a folder first. So let's say we will create a folder, new folder, and we will rename it flow over a cylinder. And inside that folder, we will save our project. Let's say this is project 1. And the extension of this file is workbench project file or .wbpj. So save it and it will save your file. So if you go to desktop and if you see the folder where you saved it, it creates two files. One is the executive file, the ANSYS workbench executive file, and other is your backup reference files or the user files. So it's very important to keep these two files together. If you save or you copied this project file and you left this user file apart, you can't open this project file in the near future. So when you copy both files and keep it in a same folder so that it can access the backups. Otherwise, you can't open the workbench file for future use. So now we will see how to export external geometry from external geometry software. So here we have SolidWorks. So if you are not comfortable with ANSYS geometry module, you can develop your own geometry in your own known drawing software and you can import that. So ANSYS geometry module can support a lot of drawing extension file. So we will see. So first let's start drawing the same dimensions and the same domain for the simulation. We will import that geometry in ANSYS geometry module. So you can draw a very quick geometry, and we have 10D. So this is our cylinder, and we will also draw our domain. So this is 60 and this is 20. That's it, and we will extrude it both sides from mid-plane. It's 10D, and we will not merge it. So extrude it. So now this is the domain, as you can see, and you have both two bodies. One is the domain, another is the cylinder. This one is the cylinder, and this one is our domain. So when you develop your geometry in another external geometry software, you save it go to save as file and name it cylinder, domain, whatever you want, and it will allow you to save in a lot of different categories or different types. Here the most common type is the IGES file. You can also save in step file, step AP203 or step AP214. You can save it 3D XML, or you can save it as ProE part, or you can also save it as SolidWorks part file. So each and every extension file NC Geometry module can take those files. So it's customary, or people like to save it as IGES file. So select IGES and save it. Now this file is saved here, as you can see, cylinder domain.IGES. Now if you go to the drawing module, open your drawing module here, and if you go to the file, you have the option here, import external geometry file. So if you click here, and in this file type you can see what type of geometry you can import from different software. So you have SAT, SAB, model, CAD file, CAD product, IGES, JM, lots of different parts. SLT part, this is SolidWorks part file, STEP, so step file. So you can import all of these extension files from different software. So we have IGES, so select this IGES and open. So now you have a import file here. It is asking you to generate. So before generate, be careful about this operation, add material. Always do add frozen, so it will import all of your parts and bodies separately. So add frozen, generate. So now you can see this is your domain, and here you have two parts, two body. This part is your cylinder, this part is your domain. So you can rename it cylinder, and you can rename it domain. So now we have to cut that cylinder from this domain. Same operation, go to create, select boolean, we need to subtract, so select subtract. Your target body is your domain, select that, apply. Your tool body is your cylinder, select that and apply, and then generate. Now you have the same domain and you draw it in SolidWorks. So if you are not comfortable using NC Geometry module, you can always go to your own software, own drawing software, and develop your geometry there and save as a different IGES or step format and then import it, and NC Geometry module will always import that file. But be careful about this boolean option, you can always change it, but the disadvantage of importing any geometry is you can't change any dimension right now. So let's say if you want to change the diameter of the cylinder, you can't change the diameter of the cylinder. But if you draw your geometry in ANSYS geometry module, you can change whatever you want. But when you import something, that dimension is fixed. So if you want to change something, you have to draw here in geometry module, or you have to go back to your software where you drew your geometry and there you change your dimensions and whatever you want, then save it as a IGES or step format and then import it again. So that's the way ANSYS geometry module works. So if you are not feeling comfortable using ANSYS geometry module, you can always go to your own software and draw your geometry, and you can import it whatever you want. Now we want to develop a 2D domain by using external software. So here we have SolidWorks. So let's draw a 2D domain here. So first of all, we will draw a circle for the cylinder. Then we will draw the domain, the rectangular domain. So let's say this is the domain. And one thing that is very confusing, that when you draw this, lot of people try to export this drawing, but in 2D you have to develop a surface which will represent the surface body. So when you develop a 2D geometry, always develop the domain surface, then you will save it as IGES or step file, then you import it. So we will go to surface and we will create the plane surface. Yes, so this is the plane 2D domain. This is our cylinder. We will save it 2D domain, and we will save it as IGES file. Save it. So here you can see clearly this is our 2D domain, and here the cylinder wall. So if you go to the geometry module, you can start over again from here. So if you go here, so click here, it will ask you the confirmation, say yes, so it will start from the beginning. So go to file, import external geometry, select your 2D domain IGES file, open it and generate. So now you have a very good 2D domain, and this circular section is your cylinder and the surface is your 2D domain. Now we will see how to import complex geometry. Let's say this is an aircraft and we want to see the flow field around this aircraft and the drag force and the lift force. So you can develop this aircraft in external geometry software, or you can download this model from Google or any free downloading CAD software. Now we have this model, but we don't have the domain. So what we have to do, we have to create the fluid domain around this plane, and then we will import that in ANSYS geometry module. So first of all, we will create the fluid domain. So our fluid domain will be a rectangle. So draw a rectangle first. Our domain will be a little bit bigger, and we will extrude it in both direction. This is direction 1, and we will also go to direction 2. Let's set the downstream a little bit bigger and unmerge this. So now we have the fluid domain, and inside that domain we have our plane. So as you can see, we have two bodies. One is the plane and another is the domain. So we will save this file, save as, go to IGES and you name it 3D complex and save it, and it will save your file. So go to ANSYS geometry module, go to file, import external geometry file, and select 3D complex, whatever you saved, open it, So before generate, you change this add material to add frozen and then generate. So it will generate. Now this is your domain and your plane. As you can see, you have two body and two parts. This one is a plane and this one is the domain. You can rename it plane, and you can change it to domain. Now we have to cut that plane from the domain. So go to create boolean subtraction. Your target body is your domain, select and apply. Your tool body is your plane, select and apply, and then generate. So now you have generated your 3D domain. So this is your domain.